We are going to convert decimal to octal and then decimal to hexadecimal and vice versa. So here first of all I would like to tell you in octal the base is 8 and digits are from 0 to 7, and in hexadecimal the base is 16 and digits are from 0 to 9 first, and then from A to F, where A represents decimal equivalent which is 10, B represents decimal equivalent which is 11, and so on up to F which represents 15. So first of all I would like to show you how to convert decimal to octal. So dear children, in this is whole number part and this one is the fractional part. So first of all we will see the whole number part. So first of all what we have to do, we have to divide this whole number part by the base of the octal which is 8. So here you can see that it is 12 and here the remainder is 4. So 12 8 are 96 and the remainder is 4. So now here what to do is again the same base and we have to divide again. This time the remainder is the quotient is 1 and the remainder is 4, and again we have to divide this by 8. Now it is 0 and the remainder is 1. So this process will continue till this number becomes 0 here, and every time we need to record the remainder at the right side. And then what we have to do, we have to go from bottom to up, recording each and every digit of the octal number system, and that is 1, 4 and 4. And after that what to do, we need to put the decimal here, and after recording this much what we need to do is just take the fractional part and this time multiply the fractional part by the base. Remember that the fractional part is always multiplied by the base, and if you divide 0.625 into 8 you will see that here the answer is 5000 and up to 3 decimal places, so it is point here. So what we need to do, whatever digit has come towards the left of this, leftmost of the decimal part will be recorded like this, and now it is 144.5, and since the and after that we need to subtract, we need to eliminate that. So if you eliminate that then the remaining part is only 0, so immediately we have to stop. If it is not, then we will continue, and again the digit which will come towards the left of that decimal point we will record it again, and maximum up to your level of class 8th we are telling the children that up to 3 significant stages we can multiply, we can repeat the same process. So this is how we have done, and now you can see that the octal equivalent of this number 100.625 is 144.5. Okay. In the same manner, we want to convert this number into this octal. So what we will do, we will record this whole number part first. So it is 175, and then start this. So that is from again the base is involved, and this time what we will do, we need to divide this number 175 by the base 8. So it is 2 here and it is 16, so 1 is remainder. Now it is 15, so 8 1 and 7 is the remainder this time. And now again we will repeat the same process. So it is 8, and here this time it is 2, 16, and this time we will be getting 5 as a remainder. And then here again we will pick the same base. So here it is 0, and here the remainder is 2. So from bottom to up, the same method we are using here. And now you can see that it is 257, and after that point will come. And now the time is to just record the fractional part. So in that case, what we need is just to write 0.125 and then multiply it by the base, and this time you will see that it is 1000. So to the and up to 3 decimal places. So here put the decimal here, and now you can see that to the left of that decimal 1 has come. So this one we will be recording like this, and after that we are eliminating this one. And now again you will see that the remaining portion is 0, so immediately we have to stop. So the octal equivalent of this decimal number 175.125 is 257.1, and the octal equivalent for this number 100.625 is 144.5. Okay. Now children, we want to convert these octal representations to decimal. So what to do here is just record this like it is 144.5, and then what we have to just follow the number line. So it is towards the left of the decimal, towards this direction it is the numbering will be 0, 1 and 2, and towards the right side it is -1, -2, like that. So children, since the base is 8, so what we need to do is it is 1, which is this digit, into base to the power 2 plus 4 into that base to the power 1 plus again this 4 into base to the power 0 plus this octal digit, which is 5 into base to the power -1. So if you solve this, you will see that it is 64, it is 32, and this one is 4 plus 5 upon 8. So if you solve this part, it is 100. And if you solve this part, this one, it is 0.625. So if you add these, you will get 100.625. Now you can see that this one is 100.62 and 5 of base 10. Earlier we converted the same from 100.2125 to 144.5. So children, I hope you have understood this. So now we would like to convert the second one, which is 257.1, and now the same method we will be following. So here it is 012 and it is -1. So that is 2 into base to the power 2 plus 5 into base to the power 1 plus 7 into the base of octal to the power 0 plus 1 into that base to the power -1. So if you solve this, you can see that it is 8 to the power 2, which is 64, and 64 into 2, which is 128, plus this one is 40, and plus this one is 7. So if you add all these together, it is what? And here it is upon 1 by 8. So it is 5, it is 7, and it is 1. So it is 175 plus that 1, that is actually 0.125. That is actually 117, sorry, 175.125. So this is what the decimal equivalent. So children, this is all about decimal to octal and octal to decimal. So I hope you have enjoyed this video. Thanks for watching.